getting more and more popular. C++ is getting more and more popular. So we're getting an enormous amount of proposals for language extensions. So please bring them. But as we've seen these proposals, they're not all going in the same direction. Right? Some people want C++ to go this way, and some want this other way, and there's tension there. So I want to talk a little bit about some of the kinds of tensions that we're running into. Now, a year and a half ago, they decided to create a new group within the committee of 5 people. Bjarne Strostrup, Howard Hinnant, Beeman Dawes, Michael Wong, and myself. And so part of our role is to sort of consult for the committee on which direction things are going to go. The nice thing is that the 5 of us don't agree. So it's an interesting challenge. All right, so one of the great questions that we ask ourselves all the time in that direction group is, who are we really making this language for, right? Are we making it for what I call avant-garde programmers, so the people who are very advanced in terms of the knowledge of the language, and they push the boundary. These are the people who invent new techniques using templates, and they give you code, and you're like, you can do that? This works? Are we really designing the language for them? And their answer is no, we're definitely not designing the language for them. Right? Yet they're a big group in the committee. Like, by nature, if you come to the committee and you start working there for a few years, you start getting the language really well. And then you come up with the ideas and say, oh, I can do this. I can do this really nifty piece of code. But if you change the language a little bit here, then I can do even more. Right? And then the question is, well, really, should we change this little language for this person that knows the language really well to make something really complicated, very nifty, but kind of specialized and makes the language even more complicated? Now, it is for competent programmers. These are the people who really get things done. I say for sure, it's for the competent programmers. So we're designing a language for people who write real software at large scale. Right? So we're definitely aiming for them. But are we only aiming for them? Well, one of the problems that we're seeing is, what about students and teachers? We're finding that more and more schools no longer teach C++ at any basic level. If you want to learn C++ in a college in the United States, I don't know how it's in Russia, but you probably have to take a graduate class in some schools. And that's sad. We really would like people to learn a language that we think is very interesting at all levels. It teaches you not just about languages, but about machines, about large projects. So we're thinking, as a committee, as language designers, can we teach these things, and can we give materials to teachers to teach these things? What about library writers? Right? C++ has powerful ways of writing libraries, but sometimes we're writing this language for the standard library and not necessarily for the whole library. So often we're seeing proposals because the standard library writers are all in the committee. Right? Obviously, they need to be there. They come and say, well, I can write my standard library a lot better if you give me this language extension. Which is, well, that's great, but there's a lot of other library writers. And so what about them? What about compiler writers? Should you help us? I'm one of those. And the answer is probably no, but if the compiler writer says, this is a really, really bad idea, you're going to slow down the compiler by a factor of 2, then maybe we should listen to them. All right, so then what is it for? Are we only targeting very large or even giant programs? Are we even interested to write tiny programs with C++, or should we just leave that to scripting languages? Often when a new language extension is proposed, it's always shown on a slide, but the only programs you really see with them is the tiny programs. Right? You never see a million-line project or a billion-line project in a proposal for a committee. And yet, that's where we have to try to think of what's going to be the impact on those really large projects that rely on C++. Is it low level versus high level? Well, it's both. Is it only for operating systems or only for applications? Again, it's both. And is it library or applications? It's both. So what I thought we would do tonight is I'll show you a few tensions, a few sort of ways that a design has to be one thing or another, and it's sort of difficult to do both. And then I'll show you examples. We can discuss them, and then you can tell me whether we made the right decision. or if you know of other decisions of the same kind that we didn't do right. So it's more of a discussion than me presenting various ideas. I made the slides today. I learned relatively recently that I did this talk, so this is not being prepared incredibly now. So one question is brevity versus clarity. What do we have here? Anybody? What's this code?
Functional
declaration. It's a function declaration. So a function taking a parameter of type stream and returning stream. That is what it is. Everyone who reads it knows that's what it is, and it's still the case in C++. Now in C++20, it's probably still the case as of today. But one proposal is that it actually means this. Right? The top, if stream is the name of a concept, and concepts are this new template feature that describes how template parameters are, it constrains them. There's a part of the committee that really would like the top to mean the same as this longer version here. Right? Now the longer version is very clear. It's a template, right, that returns something of type str. Returns str, takes a str, and the template parameter str has a constraint. So it requires that str satisfies the concept stream. Okay. Now, if you look at the top, for a human, there's no difference between a function and a function template anymore. You have to know exactly what stream is. You have to know whether it's a type or a concept. Depending on which of the two it is, it'll be something else. So which do you prefer? Do you prefer that we only allow the long version, which is very clear, very readable? Or do you also want to be able to write the brief version? Opinions?
I mean, as long as tools support the hiding all the explicit data, I don't mind the explicit long version.
Mm-hmm.
I mean, that's a tendency. Definitely, we could work accommodate with the tool developers like the brains to make it better and start for the explicit version.
All right. Oh, there's one more thing I should show you. There is a third version, this one. There is a shorthand where you can say, instead of saying type name, you can say a concept here and this. And that will be that is currently in the draft of the C++20. So the second and third are there, the first is not, because there's a lot of controversy. I'm in the camp, I happen to be in the camp that doesn't like the first one very much. I like to, when I see a function, I think it's a function. Dimitri.
What about the other syntax that was originally proposed by Andrew Sada? It was called, if I remember correctly, it was called template introduction syntax.
Yes, I didn't put that here. So there is a fourth syntax. I didn't want to talk it here because it's sort of different. It uses brace notation, right?
It uses serial.
Yes. I'm with you. But I do not understand that syntax. I mean, I understand it, but I don't understand why people want it. But I understand why people want the first one. It is very brief, right? It is the shortest expression of your intention. It's just, it requires you to have a lot of context to understand what it means. For compile, that's not a problem. For a human, it's different. So I've got one person said that, and I agree with you. Basically, if you have good tools, it can make a lot of the larger declarations sort of readable and can hide parts that maybe you're not interested at this particular time. Conversely, a tool could probably help you highlight the top one with different colors or something. So if you have that kind of tool in your editor, maybe it's workable. Any questions, opinions, inputs? Do you think there's other places in the standard where we went too much on the verbose side, verbose meaning lots of syntax, or where we have the syntax is too short for what you want to do today? All right, I'll show you another one later on another talk. Oh, go ahead, Anthony.
How do we going, if there is a concept that accepts two template parameters, how the last syntax look like?
So if they're two independent concepts, one concept.
One concept and
You cannot. So this only works for the special case of a concept applied to one type. Otherwise, you have to fall back on the middle one.
What if the parameter of template is template?
Template parameter?
Yes.
Currently, concepts are only on type parameters, so not on non-types and not on.
What about non?
Sorry?
What about non-type template parameters like integers? I think that originally in original proposal it worked. I mean in concept.
Oh, actually, no. I'm thinking C++. No, here a concept is actually it's almost like a concept per function that returns bool, almost. And so you could make a concept per function that takes a template parameter or a non-type. That will work. But the short notation, I don't actually know if it works with template parameter. That's a good question. I think it does.
I tried with concepts like in a GCC implementation and it works fine with all template parameters.
Right.
But I'm not sure what is currently in the C++ draft.
It probably will work,
Mm.
but I won't swear for it because I didn't think of it when we. So what happened is concepts were proposed as a big feature, and parts of it were cut out and put in the standard. And I was part of the people who helped doing that, but I don't remember where we did the cut. I do know that the first one is no longer available. Anyway, how many people are vaguely familiar with concepts in this room? All right, maybe I should have chosen a better example. Sorry about that. Well, I have another one here that's a little bit interesting. Anyone finds this code strange? 6 equals 0? Yeah. So this code is now valid, but was not valid until C++ 17. What it is a bit field of length 6, default initialized to 0. In C++ 11, we added this default initialized feature, right? It's sometimes called non-static data memory initializer, now it's called default memory initializer. So we added that, and then someone noticed, wait a minute, it doesn't really work for bit fields because you get this kind of stuff, right? 6 equals 0, that doesn't make any sense. So let's disallow that on bit fields. So we disallowed it on bit fields, C++ 11, C++ 14, but then someone came back and said, I really want a bit field because I got bit fields all over my program. I have bit fields all over my program. So then we started exploring syntax for it. And we tried all kinds of things. Like we tried to put square brackets around the :6, or a slash before the equal, or all kinds of things to try to not have this funny expression that says 6 equals 0 on a line. In fact, for a while we thought this could not be even parsed. But it turns out it could be parsed fairly easily because the length of a bit field is not a general expression. It's an expression that's called, I think, conditional expression. You can't have an assignment at that level. So if there's an equal, you have finished the expression. So that is now valid. So this is a place where the committee has decided for brevity. Right? So we have the shortest possible syntax, maybe not the clearest syntax, I don't know. How do you feel about that decision?
Fine.
Good? All right. So now you can default initialize your fields like any other non-static data member. So that's my first tension, things where we have to choose between something very compact or something that's more readable. I'm going to move on the second one, unless you have questions or you want to talk about some tension that you have run into that you wish had gone another way. All right, let's move on. Oh, I hate this one. Consistency versus intuition. This happens a lot in C++. We often come up with a language feature and we put a simple rule on it. This starts way back in the 80s, overload resolution, right? There's a simple rule says, okay, here's the ordering of how well something matches. Right? There were just 4 rules, I think. And just apply that. And so then people start using that, it's great, and someone says, wait a minute, I have this case, it's sort of surprising that it has this outcome. Could we add one more rule so that my case now becomes intuitive? And said, okay, let's add one more rule. And this has happened every few months. There's a new overload resolution rule that goes into the standard. If you know the rules, good for you. I don't know them anymore. There's so many of them. But this is a C++ 17 feature that I want to talk about. We recently put in, and I was very opposed to it. I lost this battle, but I get to fight again in this room. Does anybody recognize this feature? So this is it's called class template argument deduction. Tuple in the declaration here of T3i has no template arguments, so we have to decide them based on the initializer 1, 2, 3. Well, there are 3 int values, so there are a bunch of rules in standard that cause us to deduce that it's really a tuple of int, int, int. Makes perfect sense. Imagine that it would be a function that you call with 1, 2, 3. You would deduce int, int, int for the your auto function type. All right. Anybody surprised by this deduction? Okay, so I move on to compose my thing. So now I have a tuple, and I put that tuple that I had there, the top tuple of 3 ints. I put it twice in braces, so I now have a tuple of int, 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 and tuple of int, int, int. Anybody surprised by this? It makes sense. The same rule, just yeah, of course. So what about this one? Instead of having 2, I have 1. What should it be? Any opinions? I'm not asking what it is. Just what you think should it be?
Tuple int.
Right. Just one tuple?
Yeah.
Oh, I'm not with you. But you're right. That's what it is, right? It's so a special rule was added to all the other rules for deduction to say that if the thing here is an instantiation of this template here, then we throw away all the rules and we just kind of make it a copy. So this is a tuple int 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 and not a tuple of a tuple int int int.
So this is atom versus list of things.
Yes, in Lisp you get similar things, yeah. But in generic programming, this is really painful because imagine that this were a pack expansion, right? Depending on how many elements are in your pack expansion, variable template, it suddenly completely changes meaning. It will work for 0, it will work for 2, but it will not work for 1. Well, no, actually, it will not work for 0 because there's nothing to derive, but it will work from 2 on, but not for 1. All right, I'll take a vote. I heard you. Who likes this and who would have liked it instead to be a tuple of a tuple of int int int? So who likes the status quo? Hands up. Okay. Who likes it the other way? Oh man, I'm losing this battle again. Oh well, I guess the committee made the right decision by this round. But you see how these are the kinds of questions we get a lot in the committee. Someone comes with a proposal, puts a couple of rules, puts a couple of examples, and then someone says, well, what about this other example? And we put it in like, well, it doesn't follow the rules. If you apply the rules, you get an answer that's a little bit surprising. And the question is, well, do we live with a surprise, or do we make everything more complicated to make the surprise go away?
I'm just curious, what do you think about the problem that deduction guides don't take into account partial specialization?
As a compiler writer, I know exactly why that rule is there. Right? It basically is not, we don't know how to do it technically. But it is a big surprise.
Inconsistent.
Sorry?
This is inconsistent.
I
I understand that this is complex in terms of compiler writing, but it is inconsistent.
It's not just in terms of compiler writing, but in terms of what the language says a partial specialization is. Everyone familiar with partial specializations? A partial specialization only provides a definition. Right? Until you have determined the arguments, you don't know which partial specialization applies. So you don't know where to look. It's a chicken and egg problem, right? So if I see this 1, 2, 3, and there is actually a partial specialization that would have done something else, I don't know until I have actually figured out whether the arguments would match the partial specialization.
But then, if in some case we decide to add some, I don't know, maybe in the future we decide to add one more partial specialization for tuple, well, this is unlikely, but still.
You could, yeah. No.
It won't hurt, because we already have deduction guides, and they will not apply to partial specialization.
That's right.
This is the problem. So it makes the standard and the standard library a little bit not extendable,
Yes.
in my opinion.
I agree with you. In fact, another problem I have with this feature is that it generates deduction guides. How many people here are familiar with deduction guides? Not bad, not bad. Okay, so I'll talk about deduction guides without introducing them, if you're okay with that. So the deduction guide is a sort of declaration that says how you should deduce things. But if you don't provide deduction guides for class templates, the compiler generates still some for you. In fact, if you provide them, it also generates some for you based on the constructors you have in the class. Now, if you wrote code in C++ 14 and you never knew there was a deduction guide out there, right, then your customer takes your code and compiles it in C++ 17 mode and starts relying on this. You don't know that your customer is doing that because you never designed it that way. Right? But it works because deduction guides kind of come automatically from your constructors. At some point, you decide to change the constructor declaration in such a way that the deduction guide doesn't work anymore. You can do that by using qualified names, for example. Your constructor is still, it has, in C++ 14, has exactly the same meaning as it had before. You just changed the way you declare a parameter. You used a qualified name instead of a non-qualified name. In C++ 17, no longer. So you break the code of your customer. Your customer comes back to you and says, you broke my code. Undo this change you made. You say, well, no, I'm still C++ 14. No, you broke my code. We have introduced a feature in the language that silently changes contract between the library writer and the client of the code. And I'm not very happy about that. It's not really consistency versus intuition, but it is related to this general feature. I don't love this feature. More opinions? Anybody else has seen this issue between consistency and intuition elsewhere? If you use list initializers, so brace initializers, there's similarly special rules for the one element case, which bothers me a little bit.
But at the end of the day, you can specify template parameters explicitly and
yes,
have
exactly.
what
yes.
you want. So
yes, and that's what I do. I don't use this feature at all. I think it's too easy to get what I thought I would get and then not get it. Yes, that's a good point. All right. Oh, here's an interesting one. The first tension was between brevity and clarity. But one class of proposals that we get a lot, well, we've had 3 or 4 now, is we would like lambda. A lot of people would like lambda expressions to be even shorter for the simple cases. Right? If you write a lambda that just returns an expression like this, some called g of x, often you have to, because it's generic, you want to say declared type of gx for the return, and you have to specify what it's going to throw, so you do something like no except g of x. It's a very common pattern. Right. So people, a couple of proposals have come forward with variations of this theme, which is let's put a new kind of syntax. Let me try something here. Oops. Where we have this new token here that just says whatever is out there is just an expression. Right? And if you do that, the compiler does this thing at the bottom automatically. Right? That's very consistent, very simple rule. Do you see the problem?
Unreadable.
Sorry?
Unreadable.
Say it again.
Unreadable. You cannot understand what is it.
Oh yes, well, it's more syntax that you have to learn. So there is that argument, right? It becomes more complicated to understand. And also, this is an expression, and there's a semicolon there. So what if you did that expression and then a call? Yeah, there's some syntax issues there. That's true. But there's actually a big technical problem in this code. I don't know if you can see it. What is X up here? I'm going to show you a little more clearly. I'm going to rewrite the lambda as the class that it represents. Right? So the lambda is a closure class. It has an operator. Because it was an auto operator, it's a template. It's not a mutable lambda, so it's const. Right? It has decal type g of x, like I said, with the x being that parameter. No except the x being that parameter. But the x inside the body is not that parameter. The x in that body has the type const. So the g of x that's in the body is not the same g of x necessarily as the one in your signature. Right? Consistency versus intuition. The consistency is you apply the rules like we just said, and then you get two different outcomes. It is very unintuitive. Did everyone understand the problem here? See the points. Let me come back to the previous slide. Sorry about that. All right. So the point at which x is captured is only within the body of a lambda. In the signature of a lambda, you don't have the captured expression, but you have still the expression as it is in the enclosing context. But because it's a non-mutable lambda, like most lambdas are not mutable, it actually becomes const inside the body, so the type changes. So it's not exactly the same type. It's a different entity, but it's also a different type. And since you call a function on it, that function could be overloaded and produce a totally different type. Right? So your decal type there may not at all be the type you expected. One might throw an exception and the other not. So you haven't actually done what you thought you did. So now this comes up, people propose this in committee and say, well, there's that problem. So we have to change the rules. Well, they say, well, change the rule for this GX. We want it not to be constant, or that's difficult. Or change the rule for that, for the one up there. Simulate what would happen inside the body. We can do that. But if you do that, you now get into consistency versus intuition. You now have a very special rule for these other kinds of lambdas. Any opinions, comments, questions?
I just hate the syntax at the second line.
Okay. Well, if you hate it, then that's great, because then we don't have to answer difficult questions afterwards. But there have been other variations of that syntax. Like, for example, change the arrow by return, and so on and so on and so on.
Has someone from Haskell or Erlang has asked for this feature? It really feels like some functional stuff.
I don't think that's their background. Do you know Barry Redson? He's one of the big. He's really trying to get this problem solved. But a lot of people in the community have they're familiar with these other languages, so they try to move some ideas from other languages into Zero+, which is nice. It's nice to look more broadly, but when you try to translate it into our constraints, it's not always easy. All right, any more questions or suggestions? Okay, so that's a rewrite. All right. Here's another thing that we often run into when we try to add something to the language. the question is, should we go for a simple solution, or should we go with a complete solution? Often people come with a proposal, and it's got all kinds of bells and whistles, and it's a huge feature that requires a lot of work on documentation, teaching, implementation, and so on. Is everyone familiar with this feature in C++17? So in C++17, you can declare a template, but it's with a non-type template parameter n, and instead of it being a, having to specify a type, you can just say auto, and the compiler will deduce a type for you. It's very, very simple, but that's not how it started off when it got to us. The first version looked something like this. This has more or less the same effect as the first line. Instead of saying type name t, you say using type name t. That creates an implicit template parameter. It's ignored for arguments. It's just put there on the side, but it's now deducible. And then you specify a non-type template parameter. That's the real parameter, but you have a name for it now, t. So there's already one advantage here, is that you now have a name for n that you can use in the definition of your template, right? If you don't, in the top you'll have to use decal type to get back to the type of n. Right? So that's the difference, but there's more difference. When you use packs, things start changing. What does the top line mean? Does it mean a bunch of non-types of all the same type, or a bunch of non-types of each individually deduced? It's actually the second. So they each individually deduced, right? Now, with the original version, you could actually choose which you wanted. You could either say they're all of the single type, or the types are themselves a pack. The difference is whether you have ellipses there or not. Right? So here's we had to make a choice. Do we want just a very easy to teach, very simple to describe feature at the top, or do we want to provide all these alternatives that you see at the bottom? How do you guys feel about that? Any options? Well, we ended up going with just the top because it's a lot simpler, and I think most people who see that line kind of intuitively know what it means, even if you have never seen that particular feature before. If you're familiar with C++14, you'll understand what this means in C++17. Questions, opinions?
And what we will have the highest variant, that's a simple, but with optional part like std is the same. And
so the question was, could we have the top one, simple, but with an extra notation where you can put constraints on the types, and you can do that with concepts, right? It's not that simple, but if you want to say, well, they all have to be the same, you could put requires and then is same on all the types. So it can be done in C++20, not in C++17. In C++17 it can be done also, but way more complicated. You have to use FINE and partial specialization and things like that. But yes, that's a good idea, and we will have it in C++20. And that will kind of make the whole problem go away. That particular problem. But so this is the kind of question that comes up quite a bit also, is, do you go with a simple to teach language feature design, or do you make a design that has all the switches and buttons that you like to choose how it works, but then it becomes much more complicated? Oh, okay. I don't have that many more, so go ahead and feel free to chime in here. Defined behavior versus undefined. This comes up a lot, not just in the committee, but everywhere. C++ and C are often criticized because we have this notion of undefined behavior. Does anyone understand what formally undefined behavior means? Let me just clarify. So when there is a construct in the language, the standard says it behaves this way, this way, this way. You have to, if you make, if you don't satisfy the following constraints, it's ill-formed, which means it's an error. The compiler has to say it is an error. But there's some parts that come in between. There's some things that the compiler doesn't have to tell you it's an error, but it's not correct. The language does not say what the behavior is, and the The compiler is allowed to do anything. You know, people joke sometimes, you know, it can erase your hard disk, but it really can. It's incredible stuff that can happen with undefined behavior. Now, why do we have undefined behavior? Anybody has opinions as to why undefined behavior is either needed or useful? So, one of the very common kinds of undefined behavior is that if you have an int type and you overflow, that's undefined behavior. At the last meeting a few weeks ago in Jacksonville, the committee decided that integers always have 2's complement representation. But the person who proposed that also proposed that if you overflow, it would then no longer be an undefined behavior, because 2's complement representation overflow is naturally a wraparound. Right? So you go from int max to int min. That's what. But we didn't do that. We refused that. There was a lot of debate. We said, no, it remains undefined behavior. Why is undefined behavior useful? Well, there's a couple of reasons. One, it sometimes allows you to do optimizations that are not otherwise allowed. I took this code just an hour before I came to this meeting, and I fed it to a compiler explorer, to GCC, and it provided this int, right? And it made this code. Inline 10 additions. Right? Let me go back. Right? Why could it do that? Well, it looks at this for loop. It sees, so I have an array R, I'm indexing it from B to B plus 10. It says I'm going plus plus, so it says, oh yeah, of course, you're going to do exactly 10 iterations. Right? So, and I just sum that, so I'll just do those 10 iterations without looping. It's super fast. Okay. Now, let me do it with, I change my I to unsigned, and my code becomes this. Way more code, right? A little bit less efficient. Not a lot less efficient, but a little bit less efficient. Why? Why is that? Well, because when it's unsigned, there is wraparound. Right? Compiler doesn't know what your B is. It could be anything. If the B plus 10 might be a smaller number than B, because there's wraparound. Right? So now you can no longer assume that there's 10 iterations there. It sort of depends what B you started with. Because if it was, you know, if you wrap around, it could be very large numbers. And so it doesn't optimize it as well. There's other cases, like say you multiply by 2 and then divide by 2. If you do int, compiler can erase that. Right? And then this you wouldn't write that, but if you do inline functions, often the compiler sees multiplication by 2 and divided by 2. If it's int, compiler can safely take that away because it knows it's not going to wrap around and change its meaning. But if you do unsigned, that is not a valid optimization. So that's one of the big advantages of undefined behavior. It allows the compiler to reason about the code and understand that certain possibilities are not possibilities or should not be possibilities. So it can move this away and optimize for what is likely what you intended. Now, of course, if you made a bug, your program is going to crash. There's another advantage is because it's known that's not possible, you can have tools that say this is an error. Right? Undefined behavior doesn't mean that the compiler is not allowed to tell you that it's an undefined behavior. So if the compiler can say, oh, wait a minute, this is going to overflow, it can give you an error message. If you're in a language where it's always guaranteed to wrap around, maybe you meant to wrap around. I can't give you an error message because maybe that's what you meant. By putting undefined behavior in place, we're creating correct and incorrect programs. There's a definition of what that is. Not everything becomes correct. Opinions? Would you rather have integers not, wrap around and be well defined that way, or are you okay with your program crashing if you overflow?
I think it's maybe very good for compiler. It can optimize in such different ways, make the program more efficient, but from programmer's perspective, I think it's usually leads to multiple bugs which are very hard to detect and fix them.
It's true. So some of these undefined behavior, in theory they cannot always be detected, and so they're hard to find. So if you violate undefined behavior, sometimes it doesn't crash, and your program does something weird, and it's like, where did it happen? Right? Now, if we gave it defined behavior, you would still get that issue though, because the truth is the compiler doesn't go out of its way to not make it wrap. So most of the time it will actually wrap. But there are other cases where, for example, crashing on pointers and stuff like that. Languages with garbage collection have that problem less.
Maybe you can advise. I don't know if there are some tools to, for example, to revert to the compiler detects and find behavior and do some optimization.
So you're saying, if the compiler does the optimization, they would report that it did some tricky optimization. Maybe it's also a bug. Maybe that's where we're going to move towards that kind of stuff. I know some GCC and Clang have backed off some of their optimizations because they were exploiting undefined behavior that is commonly used and that people commonly assume happens. For example, Clang does not optimize its code this way.
I don't know how hard it would be to add feature that some meta information, that a tag or attribute or something to explicitly say this won't wrap. You are allowed to optimize it for sure.
Okay. Yeah, it's not hard. It would be a different type.
Yeah.
Yeah. Either different type, or you could do it in operation. But should it go that way, or do you want to say then this will wrap? I want this to wrap.
I mean, to make wrap defined, but make an explicit way to say that this won't wrap to you are free to make any optimization in this place. It's like unsafe.
Right. Yeah. So yes, we can add annotations. It does mean that all this, this stupid little thing makes a significant difference in the performance of certain code bases, large code bases. And so they would suddenly have a regression in performance, and they would have to go through and put that annotation everywhere to get back what they have. And there's, again, the committee is a large number of people, right? Any one of you could come and participate and vote. And so every group has its little things it finds important. And we have a lot of people who find performance super important. All right? It's a really interesting problem. In fact, it's so interesting that the committee has created a new study group. No longer new, it's been around for a few years now, but there's a study group dedicated to undefined behavior. This thing is called SG12. And so every time the committee meets, they usually also meet at least one day where they look at all these undefined behaviors and decide, well, should we keep it or should we try to specify exactly what should happen here? But it's always a big debate because it's hard for us to agree on that. All right. And this is my last slide, actually. When there is a proposal, we have a whole huge language already, and you want to add something, and maybe it's something really nice and really fundamental. Are you going to bring it in as a revolution or as an evolution? I'll give two examples of this. It's just short examples. One is lambda expressions. When lambda expressions came in, people started talking about inventing a new class of types. So it wouldn't be a class type, not an enum type, not a function type. It would be a new thing called closure type. Now, when you add a new class of types, C++, everything changes. Like everything that talks about types now has to rethink about, well, what does it mean to call a closure? What does it mean to assign a closure? What does it mean? It's a completely new thing. That would have been the revolution. Instead, Jaakko Järvi, he's the person who brought lambdas into the language, said, well, we already have function objects. There's also already something that means what we want. It's very much like a closure. Let's just make lambdas produce function objects, class types, regular class types. And it's been fantastic. It's a very popular feature. How many people here do use lambdas regularly? Yeah, so you're proving my point. It's very popular. But once in a while, there's still voices that come up and say, you know, it's really a pain as a class. For example, last week on the Reflector people, I think it was last week, people talked about, well, can it be a final class? Is the compiler allowed to put final on the lambda? And I think the general agreement is it shouldn't be allowed. You should be allowed to derive from the closure type of a lambda. And someone else says, oh no, we should not be able to do that. That is crazy talk. You know, in fact, this shouldn't be even a class at all. So you know, we're not going to revisit that. But there are some people who feel that it should have been a revolution instead of an evolution for lambdas. Another example is C++X concepts. So we talked a little bit about concepts. There, you can make a template and you can put constraints on the template parameters. Right? You can say for each template parameter, it has to be this way or that way. You have to be able to add two values of it together. It should not have this structure. So some constraints like that. We tried that 10 years ago. Doug Greger did an enormous amount of work. He actually implemented everything. And the way he did it, it was so powerful that the compiler can look at the template and completely understand what it does. Right? So once you've compiled the template, when you instantiate it, there won't be errors because it applies the constraints not only where you instantiate the template, but also in the template definition. And he added all kinds of features to it with things called concept maps. So say you have a template that accepts iterators, standard iterators. Now you wrote code a long time ago, you have a library that has an iterator, but it's not a standard iterator. The interface is a little bit different. He provided a feature that can translate one to the other. So if you could express the standard interface as in terms of this other interface, you could write that, and now your template would work automatically. Very, very powerful. Now, we worked as a committee on that for years and years and years, and eventually had to pull it in the last minute because we realized we had made something so big, so revolutionary, that we could not get it right. It was taking too much time, and remember this was called C++OX, and it ended up being called C++11. That was because of concepts were pushing the boundary, and you know, by I think 2008 or 2009, I forgot when we pulled them out. We said, okay, we're not going to be done even in 5 years. Let's pull it out, and people were very sad about that. What did we do for C++20? Bjarne came back and said, you know, I just have a very simple proposal. We forget about concept maps, forget about parsing template definitions, just as the concepts. Just, you know, you just evaluate these constants functions, and if they all say true, then it's okay. Then your template is valid, and if one of them says false, then it's invalid, you give an error. Much, much smaller, so evolutionary. It doesn't solve everything, doesn't do the concept map thing. Unfortunately, I don't even think we will be able to evolve it slowly to where you can do what C++X concepts could do. So we lost that. That's a bit simple versus the other contention, simple versus complete. It is a simpler solution that will never be completed. But we will have in C++20. That's a compromise. All right, that's what I have for this talk. If you guys have questions, you can talk about anything, or personal questions for me, everything's good.
Could you go back to page with typical type of lambda and no exact concept when you try to implement implementation?
Yes, this one?
I want to understand, is it such frequent situation that we don't like the code is below? Is it such frequent so that we need to implement new mutation?
Oh,
is it
according to the people who propose it, this happens a lot. And if you leave this out, it's incorrect. You get 5
such a
stars.
lot.
Sorry?
Such a lot, so we need to introduce.
That's why they bring it to the community. I have been able to live without this for, you know, I implemented lambdas in 2008 or so it's been 10 years, and I haven't felt the terrible need to be able to do this. But they write a certain class of programs where this shows up a lot, and they use these expressions
as a building block for something a lot more. So it's not just that they need a long lambda, they have a lot of these little lambdas all mixed up in their expressions. These are smart guys. They are the avant-garde programs. Remember, the people who push the limit, they're in this camp for sure. And we're not designing the language for them, but I understand why they want it.
Question. Maybe you can say something about imports of models.
People. Can I have a proposition? Maybe people would bring microphone. And yes, because
we have to.
What do you think about new concept of modules, using of modules, and like in Python?
So we've been working on modules in C++ since about 2005. The first proposal was actually from me. So I made a proposal and we started evolving it. Then C++ 11 was slipping. Before we took out concepts, we took out a bunch of other things because it was slipping. Modules got taken out. And a new group was created called SG2 that studied modules. That group has moved forward and has created a document, mostly work from Gabi Dos-Reis, who is at Microsoft, called the Modules TS, where we now have, which recommends that compilers implement a module feature. It's not part of C++ 17 or C++ 20. There's a recommendation to implementers to implement it so we can experience and gain experience with it. And so there is a form of modules. It is controversial because in order to use that feature, you probably have to rewrite your headers. Right? Now, there are companies, including Google, they're the most vocal about this, who say, we cannot do that, it's too much. Right? We have billions of lines of code, literally, and we do not want to rewrite all that code. We think we can design modules so that you don't have to rewrite the headers. And in fact, they have done that because the client implementation has modules built in that has external files to describe. If you have a well-behaved header file, it can treat it as a module. So they've come back to the committee several times and said, please take this from us, take this idea from us, because otherwise we will never be able to adopt modules. So the current status is that Gabi, who has the Microsoft proposal, which is very clean, but doesn't have as easy of a transition model, and Google, they're working together to try to unify this. I think we will find a common ground. I would like modules to be in C++ 20. I think it will be there, but it's going to be sharp. It might be close. So we may or may not have modules in C++ 20, but there's a specification that's moving on and is progressing. The one thing I'm worried about is that once we have it at scale, it will not be as good as we hoped it would be. Headers feel so bad, but they parallelize really well. When you do a parallel build, because there's no dependencies between the header, I can compile two, I get all of the headers one after another. If you organize your source code well, you can build really fast. For parallel builds, not for single builds. So if you do an incremental build, modules will be awesome. But for parallel builds, I think people might find that the time to build all of the modules is actually quite long, and you create dependency because you first have to build the module, only then can you build something that depends on the module. Whereas with a header, you just distribute all the headers, all the source to different machines, and they all build in parallel. So we'll see how it works out. I'm hoping it'll work great. I was one of the first proponents of it. The current proposal is similar to what I had originally written. And that's why we have this TS process. We are implementing it. My company is implementing modules right now, and we'll hopefully get good data on how good it is in practice. But because headers, it scales well for parallel builds, but it's not good for many other reasons. It scales poorly for incremental builds, and the macro situation is just horrible. Go ahead.
Yes, I have a question. Yes, thank you. You talked about
the difference between revolution and evolution, yes. And you told that the evolution is better, maybe, and we get not big proposal and less valuable product, something that will be in next standards, yes, and we can use it. But we had a bunch of things, lots of things, like meta classes, like modules, like ranges, yes. We waited coroutines for 5 years, yes. And why? What the source of problem? Why not everyone just say, we're gonna get little, not complex, yes, the less but working solution, and move it, like push it to the draft. What the source? We got lots of proposals, but they hang out for years. Yes, we just can't see this. Like we can't see meta classes in this standard. Yes, I hope we got it in 25 years or something.
Yeah, 22,
yes.
26.
So, and my question: what the source? Yes. Okay.
Slow down.
So source of slowdown and these complex decisions, not decisions, the complex of proposals. Can we, or maybe we just send the entropy down and the complex less, yes, and give the less but more proposals, yes. Like why didn't it was good.
So I'll reformulate it, and then you tell me if I understand it right. So you're asking what is holding up the proposals, and why can't we make more small proposals instead of a few?
Simpler and simpler.
Yes. There's a lot of things play into this. Do you know the bike shed story? The bike shed story. The word bike shed. You'll hear it a lot in the committee. The story goes. This book was written a long time ago. There were some executives. They were given a question about a nuclear reactor. They were the board of directors for a nuclear facility, and they were given a question. And they met, and the experts had given their opinions, and they said, "Okay, you have to give yes or no on this big decision here about nuclear reactor." And they looked at it and said, "Well, the experts all seem to agree, so that's okay. We sign off." Big thing went through. Then the next on their agenda is like, oh, they're going to have a bike shed that they're going to, bike shed is like to make bicycles, like a little rack to put bicycles in. They're going to build one for the workers at the nuclear plant. And they want us to sign off that it will be painted red. Oh no, we're not going to paint it red. I think it should be green. Here was a very simple little decision that had to be made, but everyone understood it perfectly well. And because everyone understood it perfectly well, everyone had a strong opinion about it. Whereas the big decision, the important decision, they didn't understand, and so they said, well, let's just trust the experts. So that's one of the things that happens a lot. We actually get, I think there were over 170 papers at the last meeting in the committee. Right? It's a lot. We have basically five days to look at all of those. They're not all proposals, but most of them are. And all of the small ones, some of them are simple, obviously useful, not a big problem, but everyone has an opinion on it. And so at the end there is a vote, and someone says, well, we could do it slightly different. And at the end of this vote, and the room is completely divided because it's so simple that we cannot agree on it. So those proposals die. No decision gets made because we need a majority, and if you have a division, you can't get a majority. You need a strong majority. Actually, you need about 2/3. Another one is that we also don't want the language to be a collection of tiny little features. We really want the language to be as few as possible simple features, but powerful features that we can combine together into stuff. Now, something like metaclasses you mentioned. My main talk. I'm not sure how many of you will be here are here at C++ Russia, but my main talk is going to touch on that. And it is being simplified at every iteration, in part because we are taking out parts that are useful for people who are not interested in metaclasses. And we're moving that to the language in smaller increments. For example, everyone is familiar with context expert. Right? last meeting, and actually thanks to work by Anthony here, we now can do new expressions. You can allocate memory in constExpr. The only constraint is that by the time you're done with your constExpr evaluation, that memory has to be deallocated. And there are going to be more and that's going to help metaclasses, believe it or not. It's one of the problems that we need to solve for metaclasses. Metaclasses has, many technical challenges. And what we're doing, we are identifying the small challenges that are not specific to metaclass, that could be useful for other people, and we're moving those separately. So C++20 will have, hopefully, quite a few new constExpr extensions. And then that will lower the overall complexity of the metaclass proposal itself. Does that answer the question?
Yes, yes.